Okay, this is section 6-6, the fundamental theorem of algebra. We're basically going to be doing two things in this section. All right? You're going to be writing in a polynomial equation given the roots or the zeros, and then you're also going to be solving an equation to find all of its roots or zeros. Okay, now these are two things that we have done already, so hopefully this will go pretty well. Now, here's the first type of problem you're going to get. Okay? You're going to be asked to write the simplest polynomial function with zeros -2, 2, and 4. And again, just like we've done in the past, you're going to set x equal to -2, x equal to 2, and x equal to 4. Right? Rewrite those as factors, okay? And then start multiplying. Okay? Remember, you can only multiply 2 at a time. So I took x plus 2 times x minus 2, and that gave me x squared minus 2x plus 2x minus 4, which then became x squared minus 4. And then I had to take it times that x minus 4 that I had from the start. I multiplied that out, all right, taking x squared minus 4 times x minus 4, and that gave me x cubed minus 4x squared minus 4x plus 16. Since it's asking me to write a polynomial function, all right, you then write it as an equation. P of x is equal to x cubed minus 4x squared minus 4x plus 16. Now, here's a second example of the same type of problem. Okay, I want to give you guys one with a fraction in it because I know how much y'all like working with fractions. But again, directions are still write the simplest polynomial function with zeros, -1, 4, and 2/3. And just like before, all right, you set x equal to -1, x equal to 4, and x equal to 2/3. And then you rewrite them as factors. Okay. And again, multiplying the first two together, all right, taking x plus 1 times x minus 4. That gave me x squared minus 4x plus x minus 4. Which I then combined the like terms and got x squared minus 3x minus 4. Then I brought down the x minus 2/3 so I could multiply those two together. Okay. So I took x squared minus 3x minus 4 times x minus 2/3, and that gave me x cubed minus 2/3 x squared minus 3x squared plus 2x minus 4x plus 8/3. And then I combined the like terms. That gave me x cubed minus 11/3 x squared minus 2x plus 8/3. And I rewrote it as a polynomial function. So P of x is equal to x cubed minus 11/3 x squared minus 2x plus 8/3. Now also in this section, there's the complex conjugate root theorem, which, again, this is something that we have discussed, maybe not in this exact setting, but we have talked about it. All right, it says if a plus bi is a root, then a minus bi is also a root. Meaning, all right, 3 plus 4i, if that is a solution or a root to an equation, all right, then 3 minus 4i is also a root or a solution. And here's a couple more examples of that, like 1 minus 5i, all right, its conjugate is 1 plus 5i. If you got 3i, its conjugate is -3i. And then -7i, its conjugate is +7i. So if one of these is a root, then the other is automatically a root also. Just as a reminder, I wanted to make sure that you guys didn't forget the rational root theorem. Remember, we talked about that in the previous section. All right, and it's almost identical to the complex conjugate root theorem, but remember, if -1 plus the square root of 2 is a root, then -1 minus the square root of 2 is also a root. Just like 3 minus the square root of 4, 3 plus the square root of 4. Okay? Since you now know the complex conjugate root theorem, you can now do the same type of problem that we were just doing, but okay, you have to remember that if there is one complex root, its conjugate is also a root. Meaning, all right, we're still doing the same thing. Write the simplest polynomial function with zeros, and on this time it's going to say 1 minus I and 2. Well, since one of your roots or zeros is x equals 1 minus I, by the complex conjugate root theorem, x equals 1 plus I also has to be a root, so you have to include it. Okay? You have to put it in yourself. And then of course x equals 2 is also a root. Now, just like before, we're going to write them as factors. Remember, what do I have to do? I have to subtract the 1 over, and I have to add the I over. That's how I get x minus 1 plus I. Same here. I have to subtract the 1 over and subtract the I over, and that gives me x minus 1 minus I. And then over here, we're subtracting the 2 over, so you get x minus 2. Now, work in pairs. Multiply the ones with I in them together first. Okay? Take x minus I, or x minus 1 plus I, times x minus 1 minus I, and multiply those two factors together first, and that will give you this. Okay? X squared minus xi minus x plus 1 plus I plus xi minus I squared. Now, what you do then is you combine all of your like terms. Okay? Now, what you have to remember, okay, as you're going to combine your like terms, remember, minus I squared is the same thing as plus 1, right? Because I squared is negative 1. So, when I combine my like terms, I ended up with x squared minus 2x plus 2. Okay. Then I had to bring down the x minus 2 factor, and I multiplied x squared minus 2x plus 2 times x minus 2, which resulted in x cubed minus 2x squared minus 2x squared plus 4x plus 2x minus 4. Which again, I combined my like terms again, and the result was x cubed minus 4x squared plus 6x minus 4. And then from there, since I was asked to write it as a polynomial function, I wrote p of x equals x cubed minus 4x squared plus 6x minus 4. Now, this example, all right, you're asked to write the simplest polynomial function with zeros at 2i, square root of 2, and 2. Now, because of the complex conjugate theorem and because of the rational root theorem, all right, you have to take into account the fact that not only is 2i a root, but negative 2i is also a root. Okay? And since the square root of 2 is a root, negative square root of 2 is also a root. So you have to make sure and include these two roots. Okay? And then of course x equals 2 is also a root. Now, again, subtract the 2i over, so you have x minus 2i. Add the 2i over, so you have x plus 2i. And then of course subtract square root of 2 over, so you have x minus square root of 2. And add the square root of 2 over, so you have x plus the square root of 2. And then subtract 2 over, so you have x minus 2. Now, here's where you're going to have to do a little bit of work. All right, there's a lot of multiplying. You're going to have to keep it all in order. Now, the first thing I did was I took x minus 2i times x plus 2i. Right? I multiplied the two things with I together first. That gave me x squared plus 2xi minus 2xi minus 4i squared. All right. Now, again, minus 4i squared is going to become plus 4i. Sorry, it's going to become plus 4. So, when I combined my like terms, I ended up with x squared plus 4. All right. I then, if you notice, I put this little blob in here to separate these two. Okay. I took x minus the square root of 2 times x plus the square root of 2. Right. I multiplied that out, and I got x squared plus x root 2 minus x root 2 minus the square root of 4. And again, the square root of 4, that's actually going to be minus 2. So when I combined my like terms, I ended up with x squared minus 2. And then this x minus 2 was from up here. All right, I brought it down. So now, I then have to multiply these two things together. Okay? So I took x squared plus 4 times x squared minus 2 and got x to the 4th minus 2x squared plus 4x squared minus 8. Combined like terms, and I got x to the 4th plus 2x squared minus 8. Which I then, okay, again, bringing the x minus 2 down, I took that one times that one, and it gave me x to the 5th minus 2x to the 4th plus 2x cubed minus 4x squared minus 8x plus 16, which I then wrote as, again, a polynomial function, so p of x equals that same thing. Now, as I said at the start, we're talking about two things in this section. Okay? The first one was, of course, writing a polynomial function given the zeros. The second one is solving a polynomial function, finding all of its zeros or all of its roots. Now, the fundamental theorem of algebra and the corollary to the fundamental theorem of algebra are important topics related to solving polynomial equations. Now, we already know it. I had to tell you it last section so you guys would know how many answers to get. Basically, the theorem and its corollary together combine to make this statement. All right, the number of roots or solutions a polynomial function has is equal to the highest power. Okay, and again, like I just said, we know that already. All right, you were told that last section. For example, all right, if you've got x to the 5th plus 2x squared plus 3x plus 1, you know that it has 5 roots or 5 solutions because the highest power is 5. Or if you're given negative 10x cubed minus 5x plus 7, you know that it has 3 roots or 3 solutions because its highest power is a 3. So, here's the type of problem you're going to get for the second part of this section. All right, you're going to be asked to solve, all right, a polynomial equation by finding all of its roots. And again, this is just what we were doing last section. Okay, the only difference now is you are probably going to get answers that involve either I or roots more often than you did last section. Okay, now the first thing I did was I looked at x to the 4th minus 3x cubed plus 5x squared minus 27x minus 36, and I tried to factor it. Problem was I couldn't factor it. Okay? So I then went and I listed all the factors of 36. All right? So plus or minus 1, 2, 3, 4, 6, 9, 12, 18, and 36. All right? Just like we've always done. And I started doing synthetic division. Okay? Now, I tried 1 first and it didn't work. So I then tried negative 1. All right? And notice, here's my work for using negative 1 with synthetic division. And I got 0 as a remainder, so that told me that it was a solution or a root to the equation. And it left me with x cubed minus 4x squared plus 9x minus 36. So I took that and I tried to factor it. And that one did factor. All right? I grouped them up. Right. Took out the x squared, left me with x minus 4. I took out the 9, that left me with x minus 4. So I have x minus 4 times x squared plus 9 is equal to 0. So I set each one equal to 0. So if I set x minus 4 equal to 0, I get x equals 4. If I set x squared plus 9 equal to 0, I get x squared equals negative 9. Take the square root of both sides, and you get that x is equal to plus or minus the square root of negative 9, which is then plus or minus 3i. So, because of the fundamental theorem of algebra and its corollary, I know that I have 4 solutions, and I have now found them. Negative 1, 4, and then positive and negative 3i. And there they are. Alright, last example. Okay, same as the previous one. Solve x to the 4th plus 4x cubed minus x squared plus 16x minus 20 equals 0 by finding all roots. Well, again, my first thing I tried was to factor it. Okay, and again, it did not factor. So I listed the factors of 20, and they are plus or minus 1, 2, 4, 5, 10, and 20. And I started doing synthetic division. Now, luckily for me, 1 worked. Okay, I got a remainder of 0, so I knew that it was a solution. Now, looking at this line here, it tells me I've got x cubed plus 5x squared plus 4x plus 20. So again, I tried to factor it, and again, it did work. I was able to group it up, took out the x squared, left me with x plus 5, took out the 4, left me with x plus 5. So, x plus 5 times x squared plus 4. Set each one equal to 0. Right? Over here, I get x equals negative 5. Over here, subtract the 4 over, take the square root of it, and I end up with plus or minus 2i. And again, I know that I have 4 solutions, and I have found them. All right? X is equal to 1, negative 5, and then positive and negative 2i. All right, last thing. All right, wouldn't be math class if you didn't have a few problems to take a look at once you got done taking notes. So, for tomorrow on page 449, I want you to do problems 2, 6, and 9.